Okay, well, welcome everybody.
Welcome,
I am Michael. This is
Tony.
we today are going through the webinar Design Assist, Revolutionising Acoustic Design. Thank you for joining us. We have people from lots of different places around the world, not just Europe.
Yeah,
it's a real pleasure having you here, so you're very, very welcome.
yeah. Warm welcome, everyone. And Michael, we did this webinar one time before today.
We did.
Unfortunately, we had some technical issues. A few of you might join this seminar instead, so welcome again, we have to say. And this time, may the technic parts be with us, so we will fulfill. Our intention is to speak no more than 1 hour. Probably shorter, hopefully shorter.
Hopefully shorter. We can take some questions.
And we take some questions in the end.
So if you do have any problems, please write them in the chat, and we have fantastic admin behind the scenes that will help sort the problems out. Should we start?
Let's start. Let's start with a little bit about Swegon for the audience, just to you know, everyone might not know Swegon as a company.
Okay, so we'll start with a very short introduction to Swegon. As well as Swegon brand itself, within the group we also have lots of other brands to the right hand side. You may recognize them as local brands in the areas you work. We have 23 production sites throughout the world. Over 4,000 employees and 10 billion SEK. That's around about €1 billion.
Yeah,
roughly.
Yeah.
Yep. So a company of a good size.
Yeah. I would say so. And we are here today. Out of the 4,100 people, we are two representing Swegon today.
Yes, we are.
We can switch to the next one and look into Swegon as a company, except being at 23 production site. Of course, we do almost everything within an HVAC system. Everything from the chillers, the air handling units, to the duct products going down to the room, and then, of course, the room unit products, such as shield beams, diffusers, radiant ceilings, fan coils. In between everything here, there is also the noise control products, which connects to the subject today. The sound attenuators, especially, we will look more into. But all of these products needs to, in one way or another, be taken care of acoustically wise, to be calculated and to be dimensioned in a good way for us to reach a demand. So that is a two-slider of Swegon, a short, like elevator pitch of the Swegon. Before we jump into the subject, let's just have a look at the agenda. It's like this. We will start to speak shortly acoustic in general, and then we will bridge into the acoustic design. The software in the behind and the software that we use internally that you can also use to calculate acoustics. And then maybe the main subject of today, how this is bridged into Revit as a plugin with all the functions added to it.
Yes.
And I'm looking forward especially to that part, because that's the newest and the latest part. But before that, I think it's proper to say maybe a little bit more about ourselves. We come from different directions into the Swegon world, I would say. As you hear, my English is not maybe that good. I'm from Sweden. I'm representing one of the factories. I'm a product manager for the acoustic portfolio within Swegon. I've been with Swegon since 10 years back now. So for a while, nearly working only with acoustic part, both taking software to the market, but also the hardware that comes with it, the silencers. And prior to that, Michael, I actually do not have HVAC experience, but I do have acoustic experience. I used to work actually with active noise cancelling at ear protection. So I have done this decibels. I'm very interested of that part, the decibels and the acoustics. And you come from a perfect other directions into this.
Absolutely, yes. My background is in design of HVAC systems, so working with Revit and other software. And my role here is supporting the Swegon teams where they interact and connect with BIM, CAD, and Anything that is on the design side of things. So if you are using one of our product models or product families in your design, then I'm here to support the teams with how they work with that.
Yeah. So you have worked a lot with designing in CAD world.
Absolutely.
Right.
Yes. Yes, that's my background.
That's your background. And I think that connects very well here. I worked a lot with the acoustic part to calculate acoustic, to bridge these together. I hope we will give you something interesting here today. We will keep it on a high level, so not very much into details like the acoustic world. A high level, you could say today, a high level, level, sorry. And then further down the road, if we need to, we can dig deeper into the subject.
Absolutely.
In a later maybe contact.
Yes, yes. We do have questions. There should be a way of typing comments or questions on your side of things, on your computers. We will come to the questions at the end. Hopefully we'll have time.
Yeah.
If there are any questions that Tony and I can't answer, we have a technical team behind us that will definitely be able to answer your questions. And if we can't get to them straight away, we'll get to them by email afterwards.
Yeah. Very good. Let's start with the one slider, acoustics. We put this one up here. I believe when you did your CADing back in the days, you had the demands, right? You knew what to design for. That was stated probably in the building regulations.
Yes.
Yeah. So in each country of Europe, you have one kind of building regulation that states what would be a base demand for acoustics. I'm speaking now. And on top of that, a building could go for a national scheme. Looking into the Nordic market, and especially in Sweden, you can rate the building A, B, and C acoustically, put the stamp on the wall, and then you have stricter demands that we need in some way to calculate. And on top of that, possibly, someone would like to create a building that has this certificate like the BREEAM or the LEED. I don't know if you ever came across that.
We have. I've worked on BREEAM projects where we're looking to create the most amount of points to get a particular level certification.
Exactly. You get a lot of points in different area, but also acoustics, to taking special care of the acoustics, if it could be stricter demands or other things, of course. So these three, we meet a lot internally when we design a system, a full system from Swegon, and we need to take care also about the acoustic calculations, of course. Sometimes that's the central part.
Yes.
And that's the baseline that we will go for or from. And the building regulation in itself, that at least in Sweden requires project documentation. So now it's obligatory to have an input with the documentation, which is also ties into what we will speak about today. With that said, we jump into the software, acoustic calculation software, acoustic design. This very software was released last year in this format. It existed a few years before that as well. Hopefully, and probably some of you already use it. If not, it's up there on the web page for you to use already today, and it's free of charge to use. It's based in the bottom of ASHRAE algorithms. So everything here and the calculations is based from ASHRAE standards. So no hocus pocus from Tony Olsson. It's the ASHRAE standards. 4 modules, you could say. Analysis module is probably where I work the most, where you will work the most as well. It's calculating from a noise source with all the duct components that you select down to an endpoint, which normally is indoor or outdoor. Could also be any place in the ductwork you like to see how much sound do I have here. Then we have a configure module where you can configure noise control products such as silencer in respect of size, attenuation, pressure drop, and so. Then there's a crosstalk modules for those who need to calculate crosstalk between different rooms where you have a wall structure, and then you take care of the ventilation or you drill a hole, and you need to figure out what will be the new value of the wall. So that what is in there as well. We will not speak about that one today. That's a different webinar. And then in the end, of course, the reporting module to support the project with project documentation. So everything you calculate, of course, can be printed and handed out. And now, I would say a few weeks back, but a few months back, maybe we should say, we released the plugin for Revit with some special features.
Exactly.
And those we will dig in deeper into than the acoustic design. But before we do that, I would share some highlights of the acoustic design, because this as a separate software is very good for you to have to calculate special things that you might not be able to do in the CAD world.
And it, of course, is the core of the Revit plugin functionality.
And it will be the core. Thank you, Michael. First of all, this is the way it looks. It's one side that we call the palette, where you have all the duct components or the functions that you need to use. A canvas in the middle, where you drag and drop your system to build a ductwork from a starting point to an end point. And in this example, it's actually a real example where myself calculated an apartment where it was a whole Swegon system from the air handling unit into the room product. And the bedroom in this case, Michael, was the demand of 30 decibels. So we had to really make sure that all noises ending up in the bedroom was below 30 decibels.
Yes.
And we did this quite simple calculation. Do not take too much time when you get to know the software. In the beginning, of course, you will struggle a little bit to know all the functions and see what you're doing. But this is the base of how the software looks and how you work with it. That's an indoor calculation. We could move up to a rooftop and consider that we need to calculate the air handling unit, and maybe especially more a chiller who can have quite high sound levels at its worst day per year. And imagine if you have a relaxing area, a patio, where you have a demand of 50 decibels. Could that be achieved with a 10-meter distance? In this case, I did the calculation. No, it didn't. I had to put in a noise barrier, which is also a function to see how much would that attenuate the sound coming from these sound sources.
I spend a lot of time doing this for projects in the UK.
Oh, you have?
Yeah, absolutely.
Yeah.
Particularly where you're next to other residential apartments.
Oh, yeah.
You're looking for not reaching over the sound levels for those other residential areas. I think this is
exactly for looking the other way to the neighbor's border, that you have a very strict demand, and if you don't reach that one, you will probably stop the building until you reach it. So of course you can do this kind of calculations with acoustic design. As well, one other thing that I believe differ from a CAD software is you can cross-check any point in your ductwork to see how much energy from inside to outside the duct you're getting. Also, how much sound will be outside the ductwork. And this is especially sensitive close to an air handling unit. Normally with big rectangular ducts are more sensitive to letting out sound. So you can simulate and be very sure what the sound levels will be outside the duct, which can affect the room that is sensitive. I will summarize this. So this is the basic of acoustic design, which will be used in the background when we are playing now with Revit soon. But all through a ductwork, air distribution system, we check for the attenuation. Also, the generation of noise at bends and branches and takeoffs based on ASHRAE standards. We have the indoor-outdoor receivers, or put the point anywhere in the duct, which is nice to check where your sound is. We have people from around the world. Some would not like to calculate with dBA, probably NC or NR instead. And of course, you can switch from these different criterias. And in the end, I would like to mention when you do work with noise control products such as silencer, not only do we give a pressure drop at a certain airflow, we also give you the possibility to set the system effect, what's before and after the silencer, to get the real pressure drop value for the silencer,
because which can make a big difference.
It can make a huge difference. That I think would be a good start to go into the Revit world, and I hand over to you, Michael, to take us through the Revit part.
Yes, thank you. So from here, you understand that we have acoustic design. When we move into the plugin, what we do is we take the functionality of acoustic design and we connect that directly into Revit, which brings us lots of benefits. We take the building data from your model. So instead of having to create room dimensions and sound outlets and inlets, all this can be captured from what you've created in the model already, from your ductwork system, from your rooms. It brings that calculation that you would otherwise have to do externally right into your design workflow. No need to export, no need to import. So we can jump right into acoustic design, run the calculations that we run, and then bring that data and also the models right back into your Revit project. So it's a real connection between acoustic design and how you work with Revit, with your project. The reason that we did it this way with a plugin, looking back over the last few years of usage, we can track where our product families go and who uses the product families and in what way. There has been a big increase in product family usage, which obviously more and more people are designing with BIM, designing with product families from our libraries. But the biggest change has been a 500% increase in usage of plugins. So for sure, we see that the people that are interacting with our BIM products are using plugins and are using plugins more and more, which gives us a fantastic opportunity. The plugin gives us a chance to build calculations and integrations in a way that otherwise we wouldn't be able to do. So we support in Revit all the way back to 2023. So if you're working with full Revit from 2023 to 2026, this will work for your Revit. At the moment, Revit LT, the light versions, we are not 100% supporting. That's something that we need to pick up ourselves behind the scenes and to see if there is a way of making Revit LT supported. But if you're working full version and any of these years, then the plugin will work great with your project. When you install it, it's a small installation file. You will get an extra tab in your ribbon. And then if you click on this tab, it opens up another ribbon bar below it where you can get access to the functions that come with acoustic design plugin.
Right.
And we'll go into the functions step by step, but this is what it will look like when you install it. I think as designer, this for me is one of the most important and interesting parts. It's taking all of the building data and your system data and bringing that into acoustic design. We can do this in one click. And as it says here, we've done it at the moment. The biggest building that we've run this through is a 70-room building. And it can scan the building, take the system data and all the spaces data, the room data, and take that into acoustic design ready to be calculated in around about 5 seconds.
So I like that.
Yes.
My first project took a little bit more than 5 seconds, but of course to CAD or design the system takes its time. But then just bring it in like this. Exactly. It's fantastic.
Yes. And this includes all the parts of the system as well. So thousands of components, duct pieces, bends, diffusers, all of them captured, moved across into acoustic design and ready to calculate.
Okay.
So we can see this. We have a little video. This is a sample project that we have worked on for this. Very simple, clear and easy to see, hopefully. A single air handling unit on the supply side, feeding 2 floors of offices with supply ductwork. So we can go through a little bit. It's a little bit of a simplistic project. Most of our projects will be a little bit more complicated, but for visualization purposes, I think this is ideal. We have 2 different floors, the ground floor, and is that about 7 offices on each floor where we're serving fresh air into them with all the ductwork sized. And if we go to duct path analysis here, this enables us to take a run from any particular sound area, so an office, a corridor, whatever it is that we're looking to measure, and then run that all the way back to the generation, to the sound source. We can change if we want a lot of these settings, but we'll jump into that in a future video.
Yep.
But here we can see the components within the system. These are the main ones, so the terminal within the room and the air handling unit on the generation side. And we can analyze this now. So in the background, it's running through that system. It's capturing all of the components, and here they are now. So it has taken, you can see the first one is the air handling unit, gold, Swagon gold air handling unit. Then we have the bends.
Standard duct components, yeah.
It has captured them, pulled them in.
Yeah.
You can see it has the acoustic data for each one, the losses and the gains,
right.
The pressure drops and the airflows through them.
Yep.
And all of that has been captured. So we can now take, if we want, a silencer as an element and drop that somewhere within the system and see how that changes the system. We can select a little bit. You can see that it's captured the connection dimension.
And the airflow.
And the airflow as well. So from here, it's filtered out the silencers that would be suitable and selected on the right-hand side what the acoustic performance of that silencer would be.
The result in the receiver, yeah?
Yeah. Now, we didn't put it exactly in the right place, and it's told us. It says that that place isn't suitable. So if we move that into a location in the ductwork that we can see, then update Revit. So now that silencer, once it is loaded, is in the system.
Nice.
There, one silencer added successfully. So we should be able to see this on the 3D model. There we go. It's put on the air handling unit just after the duct. The silencer is loaded. The product family is in there, and we can then calculate the space with that silencer in the system. So that's one way of doing it, getting in directly into acoustic design and dropping your products in as you would normally through acoustic design.
Yeah.
But from Revit. So that's one function of how to work with it. Another way, if you already know maybe what kind of silencer you want to put and where you want to put it, you can almost drag and drop. Yeah. So I'll show you how this works now. So again, the same project, the same view, plan from the top. We've taken the silencer work that we've just done back out again. We're back to a completely clean project. And we go up to the top and we have add silencer on the left-hand side. So just with the one click, it jumps us straight into all of our products that are available through acoustic design through the interface. We can filter to choose exactly the right product that we want for the project. And also the standards. So if what information is available for that product, we can jump into the product's data a little bit. So we can see what the sounds might be before the silencer, after the silencer, and also the silencer performance details. And a little bit of information on the silencer itself, if you're looking for dimensional information or just what it would look like when it's in the space. And then we can open that in Revit. And there you see you have the little silencer icon on the mouse, a cursor, and you can click that and drop that into duct as many times as you want. It will always drop from that range that you've selected.
Okay.
Into duct wherever. It drops it in, and first of all, it changes the ductwork to suit the silencer. But then if you want, and this is something you can change in the settings, you can make it so it automatically changes the silencers to suit the duct. So it picks from the range, picks the right size silencer to fit the particular duct that you want, and then updates it. And that is the family. So that's our silencer family loaded in the project, ready to be tested for performance when we want to look at what the effect of that is in the room. So really fast, really quite an easy and simple way of pulling silencers into your model.
Oh, really?
But still, that's one silencer at a time, and we haven't done any room calculations yet.
No.
This is just pulling silencers in. So, design assist, we're looking at two different things here. We've got acoustic design, which is how we connect to our acoustic calculation engine, and then design assist. So design assist is an add-in method of using the calculation possibilities and the data that we get from Revit and enhancing how we design our products with it.
Right.
Design assist connected to acoustic design is the first iteration of this. but do keep a lookout because there will be future ones too. In this case, we are looking at bringing the model data from our Revit model and also the standard calculations, the type of calculations that we use in acoustic design, and automatically building this into how we run through the rooms, the spaces, and the products within our model. We focus on the tricky work, the repetitive work, the things you have to do lots and lots, which silencers are great for this because you tend to have a lot of silencers in a project, usually not too much different, and lots of calculations needed to get to the point where you're 100% confident about the sound in your project. We don't play with any of the creative inputs, so that's entirely up to you to do the creative side of things, select what systems you want. There's lots of stages at which point you can control how the automated calculations work. It isn't just a black box where you press a button and have no idea how it comes to the end. Full control is still with the designer. So we have, taking back a step, two buttons, the one on the bottom left, space calculation, and the one on the bottom right, automatic adding silencers. Starting with the first one, the bottom left one in the bar, space calculation. So the idea of this is to take a building and to calculate the sound levels in all the rooms in that building in a simple way. So instead of having to run it through acoustic design, which is quite simple, but maybe takes a long time in terms of the amount of information you have to go backwards and forwards with into acoustic design, we hopefully make that a little bit faster. So jumping back into the video, exactly the same project. We've taken the silencers that we put in back out again. So we're starting again with a clean project. And this will show how we run room calculations. Now, at the moment, these calculations are run based on the center of the spaces. So if you go on a space, you have the little X, but we can move that calculation point to anywhere in the room. So if you have a particular sensitive point, if the CEO is sat in one corner, then you can move the calculation point to that part of the room. Lots of different room templates. So if your room is particularly reflective or particularly absorptive, you can set it. And also there is a chance to create custom rooms. So if you have a room that you know the specific performance of that room.
So you can set your own absorption factor.
Exactly that. So here we go.
Like there, okay.
You can change according to the sound absorption of that particular room. You can also change the requirement. So you may have a room where you have a particularly tight requirement.
Go for a lead building.
Exactly. Yeah. Or maybe the room where the CEO sleeps.
Exactly.
So where you need a very, very low sound level. And you can set those sound levels there. In this case, we select all rooms, so 29 spaces in the room. And here we have pulled all the components that we have the information for in the room. You can see the list in the whole building. And then when we click next, it runs a little bit of a calculation behind the scenes. So now it's counted the number of spaces. It told us that one space, the requirement is met. 9 spaces, we're close. Around about 3 dB over is what we consider to be close. And 8, we really haven't met the sound requirement.
Based on our stated requirements.
Based on our stated requirements for those rooms. Now, it'd be interesting to see where they are. As you can see, the rooms on this particular floor, which is the ground floor, the ones that are closest to the air handling unit, seem to be the ones where we have the largest noise problem.
That makes sense.
Yeah, that's typical. And then on the first floor, we have a little bit of a better situation, maybe further away from the air handling unit. But still, the rooms closest have the problems. So we have this color scheme overlay that you can switch off and then back on again. But it gives you a good example, a good idea of which rooms are from a purely visual view. But then you can go into every room and find out exactly what the performance of that room is. So again, within a few seconds, you've run the room calculation for every space in the building. And you can have some confidence that what the calculation says, depending on how you've arranged it, and again, it's good information in, you get good information out, that this will be the space calculation for your particular building.
A question from my side. I saw when we did this calculation, obviously here is Swegon products, and we have control to bring out the data from the Swegon products, both generated noise and attenuation on, for example, diffusers. What if it was other vendors' products?
No,
Could that be
absolutely.
used as well?
We can do that. So as part of the process, where we have the full list of products,
Yeah.
if you've put in, for example, another manufacturer's air handling unit, it would exist as an air handling unit. We would recognize it. We wouldn't have the specific data for that air handling unit. We don't hold data for everybody's air handling units, but you can go in there and you can enter.
And you manually enter it.
Manually enter, and it will run the calculation just the same. So it will be super fast if you're using Swagon products. It'll be a little bit slower if using other manufacturers, and you'll have to do a little bit of data entry, but still the calculation process is just as fast.
Yep.
And it works in exactly the same way.
Yeah.
Okay, so that is the first of the two buttons. That is the room calculation. Now we jump to the auto add silencer. So with this, the concept is what we want to do is to make it super simple, super easy to be able to place silencers in the ductwork to serve the rooms based on the calculations that we've made there in the previous run. So again, we have a little video using exactly the same system. And we do start a little bit from scratch because the first step is to run the room calculation. But if we go to this, click our single button auto add silencer, we have the option of crosstalk attenuators, which place silencers in every room to be able to stop noise from one room to the next through the ductwork. We can turn that on and off. We can select the silencers that we want the system to select from. So if you want to restrict the range down to just a particular type of silencer, you can do that too. And exactly the same with the room silencers. So we treat the noise at the source. So from this case, it's the air handling unit, and we treat the noise as it enters the room if we need it. Here we capture all the room spaces. And just like we went through before, you can change the requirements of the room as well as the sound absorption of the room and be able to make this exactly custom for your particular project. Very quick and very easy. And then you can select however many spaces you want to select for. Doesn't have to be everything if you want to focus on a particular floor. And then in the background, you can see that we've scanned the room again. We've pulled all the products into the calculation. And if we click auto add silencer now, in the background, it's running all of the calculations from our sources to our rooms, to the receiver side. And it's calculating what would be the best place to put the silencers, what would be the right size to put them in, and fitting that within the duct system in a smart way. We can't put silencers where we can't physically put silencers in the system. So we started off with 1 room okay, 8 rooms we were very close, and 9 rooms with a problem. And after our auto silencer placing, we have 15 rooms that are great, 1 room that is still red. If you remember, we dropped a few of the sound levels to really quite low. So it could be that we don't achieve 100% of these rooms, but we have, I think, 23 dB in one of these rooms.
You put tough demands.
We did put tough demands on this one. So as you can see, all our rooms are green, and we have 1 silencer that's required for the room that is one of the closest to the air handling unit. And on the ground floor view, you can see we have 1 silencer that's been placed on the air handling unit, which has dropped everything down a little bit. And the worst room's the top left. So even though we have a very big silencer in those rooms, and also the red one, we haven't quite met the sound requirements. Which I think is unusually high sound requirements for those spaces. And here we can see that these silencers have been placed in the model. We have them in as Revit families loaded within the model with all the performance data of those particular silencers in that ductwork with the calculation. So no additional data is needed to be added in to those within the model. Everything is captured straight away. So very quickly, we have a project there where not only have we calculated it, but we've also solved our sound problems. We also flagged up areas that might be a concern where you may need to look at it either on the design side or maybe on a requirement side. If we have a room where we really need 23 dBA, then maybe we need a different way of looking at that system. But
that is impressive. And again, just to repeat, did you say that first we do the calculation of the big sound source, like the air handling unit?
Exactly.
Place a silencer there, then do a recalculation and see if we meet the demands. Then start the placing and do a recalculation.
Exactly.
See if we need to change.
Always more efficient to treat the sound at the source, and then run through the system and then treat the sound closer to the receiver side of things after that.
Yeah, we would do the same, but manually. Start at the sound source and then see if we need to add a lot. So looks good.
Great. Yeah. So how it works is, what it isn't is AI. This is not generative AI. It isn't algorithms that we don't understand. This is standard calculations using standard data, using standard methods, using the ASHRAE methods that are built into acoustic design. It works so well because we already have the data there. We have the data within the Revit model that you've created, or the architect has created. We have your system data from your ductwork. We have our data from our products. So our acoustic data, and also any other of our products that you've included in the system, all that is there. So we can combine all of that and automate the calculations to make this a very fast and simple process to go from a system where you're not sure about exactly what noise levels you will get to a system where you have the noise levels treated or flagged if there is a problem. So there we go. That's how it works. Now, the calculation is often one of the first steps. Then we need to select the products, but then the schedules and what we do with the information of the products that are selected is often the key when you're working on design. You have to take the designs into project information, maybe into tender information, maybe onwards. So the calculation schedules are important. We have two schedules types and one export function. So we have the space calculation schedule where we have every room. And here we have a detailed list of exactly what's been achieved in those rooms with the new sound system. We have the silencer schedule where we list all of the products that have been placed within the project and their performance details, dimensions, and all characteristics of those products within that schedule, all ready to go. So if you want, that can be exported and used in your specification. And then we can share it. So we have a share function which runs through acoustic design, works in the same way. You can share it to a colleague, and a colleague can look through the silencers that have been selected, or one of our contacts. What we don't share, we don't take any of the BIM project data from it. That stays within Revit, it stays within your program. We only pull out the product information, the list of Svegon products that have been selected for that project. A good way of working with this might be to send it to your Svegon contact and get them to check your selections, perhaps, have a look and see if that's the right type of silencer for your project, or send a quotation based on what you've selected. But this is for you to control. You can share that product list with whoever it is you want to share it with. And that rounds it up, really. I think one of the key things that I want to let everybody know is that we do have a big team that sits behind Tony and I. We have product specialists. Tony is our product specialist for the acoustics. But when we're looking at the other products, we have the specialists behind us, and we have BIM specialists ready to support in case you have questions or problems when working through this. BIMsupport@svegon.com is the central location email. We try to move as fast as we can because we understand that if you're having a problem working with this, then that's a problem right in your working day. And a delay, it has a big impact, just like it would if anybody's working day gets paused. So we try to move as fast as we can for replies and resolving issues. Explore more. We have lots of BIM libraries, lots of places to find our families and other BIM and design applications and tools, as well as the full range of all our products, of which there is quite a lot. So svegon.com is a great place to start, and from there you can explore to find all the things you want to find.
I'm not a Revit user myself, since I don't know Revit. But if I would, I would have gone to download this immediately. I mean, it looks fantastic. I'm using the acoustic design, so I'm playing around with that, and I love it. But to be able to do this calculation with the help of acoustic design in the background, it looks good. Where do you find the download for the Revit plugin?
Well, you can find it if you go to svegon.com. We have a section within BIM, and you can find your way through to that. But what we'll do with the email address that we'll send out after this, which will include the recording of the video, it'll also include links to the landing page for acoustic design itself, as well as the plugin. So if you did want to download it, you would just follow the links and you can download the version that's right for you, and then get started. And also in there will be the email address for support if you do have questions.
Great. And you also, again, to repeat, you find acoustic design also on the svegon.com under software. To wrap this up and then check if we have any questions from this is, we brought acoustic design to the market, and we really worked a few years to get it to this version we have now. So in parallel, we knew we could start with a Revit plugin, or you could start with a Revit plugin, Michael. So feel free, both softwares are free to use. I can also say like this, both softwares, you don't even have to dimension any Svegon products if you don't like. If you use other products, it's an open software to calculate in general acoustic. But of course, it makes it more easy to work with the Svegon products within the software. That's natural because we need to use it ourselves in our daily work. Feel free, go ahead, download and try it out, and contact us on the BIM support email if there is any questions or trouble.
Or just feedback. We would love to find out how you work with it when you do work with it. So yeah, even if it's all positive and you're enjoying it, then that is also good feedback too. Okay, so we may have some questions.
Yeah.
If we move to that step.
Let us see if we do have questions.
Okay. We do. So when we used, this is from Farhad, when we used the auto selector, it didn't add attenuators for some of the rooms. Does this mean the sound level in those rooms is below? I think it did. If you're talking about the model room that we just did, it only takes a silencer for the rooms that we have a diffuser in. So it looks for it runs through the ventilation system, looks for the rooms that have diffusers, and then runs the calculations on those rooms. So there were some rooms like the reception area that we hadn't treated with the ventilation system. So we didn't run a calculation and we didn't have a silencer selected for those rooms. And also we certainly wouldn't select a silencer in a room where a silencer wasn't needed.
No.
So another great thing with this is it may mean that you end up with less silencers, an easier project to install, maybe a lower cost to your project, because we can calculate every room correctly.
Another question, should the ducts and fittings for that use the Svegon duct family, or does it work with all duct families?
It works with all duct families, a little bit like you said, Tony. You can not only use any product from anywhere else, you can enter product data. The duct fittings and families that can be used in this, if you're using Revit and Revit MEP and the standard duct fittings that come through that, it works with that. All it does is it takes the dimensions, the airflow rates of your system as it runs through that duct, and it uses that for calculation. So absolutely we'll use standard ductwork and fittings, as well as anything that is Svegon branded.
No.
Tiny bit faster if you're using it with our products, because we already have the data in there already. You don't need to enter anything yourself.
Great. Paul asked, can your calculations be imported into StabiCAD? And I don't know what StabiCAD is. Do you know what StabiCAD is?
I do, yes.
You do?
Yes,
okay.
Yes. StabiCAD is a ventilation design software. So it usually sits in parallel. You may do the building design in Revit and then go out and take that information and do the ventilation system design in StabiCAD.
Yeah.
We are working with different ways that we can connect it in. Certainly our data for the building can be exported in the normal way that Revit exports spaces data. So if that then can be imported into StabiCAD, you can then take it. I think it can then be exported from Revit into building energy calculations, this kind of software too. So if you can export from Revit normally, then you can export the data. You can export through IFC as well, with the room spaces data, with the sound levels within that as well. It would be interesting to see, Paul, because we can't test this with every single software, it would be interesting to see if how your experiences are if you do try and move from Revit after the design, after the calculations, and into StabiCAD. Also interesting if you design in StabiCAD and then bring that into Revit and see if you can run the sound levels that way too. Yeah, it would be great to have a conversation after you've tried.
Thank you for that question. See if we have anything more here. We have a question. Do you generally advocate sound attenuators built into air handling units, low pressure drop, or as opposed to ductwork when it is often more difficult to accommodate the 2 to 3 diameter straight ducting? Okay, I see your point, Paul. I would answer like this, that of course internally within Swegon, when we develop products, and especially if a product should be added to another product like an air handling unit, of course we optimize it as good as possible with both the attenuation and pressure drop, knowing our air handling units. Whereas if you put a ducted silencer after air handling unit, you are in most cases in a narrow space where there might be just close to the fan and then a band afterwards, which means you build pressure drop. So I would say, without having a crystal clear answer, that it's wise to select a silencer that is designed together with the air handling unit, because normally you get the optimal pressure drop versus attenuation. Whereas it sometimes can be a challenge, you need to take that away and design in an attenuator that goes higher, which often is at the cost of a higher pressure drop. Calculate with the system effect if you don't have the 2 to 3 diameter straight ducting, because what we essentially do when we measure a silencer and the pressure drop, it's with the 4 diameters before and after the silencer, and everything else is a simulation with the system effect. So I don't know if that was an answer, but that was at least a try to an answer to how I understand the question.
From the Revit side of things, if you've selected it using AHU Designer, our selection software, that should be pulled into Revit. So where we had an air handling unit on our model that didn't have any silencers, those silencers should come through, and also the sound data generated by that air handling unit plus the internal silencers should be pulled into the model and be part of the calculations. If then you need further silencers, then the calculation will tell you, and you can take it from
there. Let us see if there is one more question. I think one more question came from Krishna. Does it also support the CIBSE standards and regulations in addition to ASHRAE and Nordic requirements? I have to honestly say, I'm not sure. We are following the ASHRAE standards and the latest standard that we could find, including inlining duct and such functions that's in the ASHRAE. The SIBS, I'm not sure. So I will state the ASHRAE standard for now, and I will read through it and get back with an email instead.
I think for the people that don't come from the UK, the SIBS is an institute that is based in the UK and it's looking at building services design within the UK for UK projects, but also for projects in around the world. It is equivalent to ASHRAE, and in a lot of cases, they do work in parallel. There's a parallel between the two.
And the question is right there, probably.
I think so. Yeah. I would imagine that although we don't follow exactly the SIBSE calculation steps, we follow the calculation steps according to ASHRAE. The end result is likely to be the same or very similar. I think that, I don't know, maybe it's something that we can look at to see if we can run the simulation following the SIBSE calculation steps rather than the ASHRAE ones.
If it differs, I don't know, actually.
Yeah, it would be interesting. Krishna, if you're working a project that is small enough to be able to run the calculation through SIBSE, it would be really interesting, and I personally would have interest and like to know how it goes, and then we can compare exactly the same project very, very quickly with what we are doing here. It would be really interesting to find out.
Well, that was the questions Thank you very much for your questions, and thank you for attending this webinar. We have nothing more, do we?
Than this? Covered everything
we covered everything for today. So please go ahead, download, start using the software, drop into the BIM support, and we meet you there.
Absolutely. Yeah.
All right.
Thank you very much.
Thank you very much. Have a further nice day.
And goodbye.
Goodbye.